Hey folks, welcome to lecture 1.3, part 1. We're talking about significant figures now, sig figs. So in the past, we've gone over units and measurements. We talked about making a measurement always results in a number and a unit. And now we're going to talk about how well do you know that number? Okay, with how much certainty or how many digits out do you know that number? So I want to start with another quote from your textbook. Uncertainty in a measurement is conveyed through the number of significant figures reported. And then they say the last sig fig in a measurement is the uncertain and estimated digit. In another word here, the greater the precision of the measuring device, the more sig figs you can report. So taking it out of the realm of numbers for a moment, but just thinking about uh, scale of answers or precision of answers, I want to ask a question. Where do you live? And think about how you would go about answering this question. Because there are actually lots of different ways to answer it. A not very useful answer would be to say, I live in the universe. Well, yes, of course. You say the solar system. Also, of course. Earth. United States. Okay, we're getting a little more information now. Iowa. You could say, if you are traveling around the world and someone asks where you're from, you might say, I'm from the United States. But if you're traveling around the United States, you would say, I'm from Iowa, right? And if you're around Iowa, you might say, I'm from Cedar Rapids, and so on, right? I live on campus. I live in Regina Hall. Here's my room number, right? If you were talking to a new friend that you just made in class and said, where do you live? You'd give them your room number, right? So the appropriate level of precision depends on the situation, right? Sometimes you just need more precision. You need to zoom in, you could say. And then the information and certainty depend on the measuring device, the precision and scale of the measuring device. If the device that you have only measures to the nearest meter, well, then that's all you know. If it measures to the nearest millimeter, well, now you can report to the nearest millimeter. Okay, so back to measurements in science. Here's two scales showing what seems to be the same weigh bowl, and the one on the left shows 10.4 on the scale, and so it only has precision to within 1/10 of a gram, and the last sig fig in the measurement is estimated, uncertain, right? So 10.4 means that uh, that last 4 is maybe fluctuating. So the actual value would be somewhere between 10.3 and 10.5. That's about all we can say, right? The scale does not go uh, with more precision than that. But if we look on the right, it says 10.4977 grams, right? So this one has precision to within 1/10,000th of a gram. And therefore, if the last digit is the one that's uncertain, we have now narrowed it down to somewhere between 10.4976 and 10.4978. So we could say it's 10.4977 plus or minus 0.0001. Okay, so the greater the precision of the measuring device, like on the right, the more sig figs you can report. On the left, if we were to say 10.49 0 grams, that would imply that we actually knew it to the nearest hundredth. It would imply that we now know we're fluctuating between 10.39 and 10.41, and we don't know that, right? So the 0 here actually, in our minds now, you have to think about this 0 changes this number, right? So 10.4 and 10.40 are not the same number, right? If this is a measured thing. That extra 0 matters. Okay, we're going to lay out some rules for all of this as we go along, but just to get you thinking about it right now, right? And every number that you measure, any value, any quantity, uh, ultimately at some point your instrument precision runs out. At some point you have to stop adding digits to your number, right? It can't go on forever. And so even if you know many, many digits, at some point you have to stop, okay? And where you stop actually matters. So any number that you measure, you have to consider the significant figures. And again here, the greater the precision of your measuring device, the more certainty you have of the value, and the more sig figs you can report. But is there such a thing as a perfect measuring device? On the last slide, I just said no, right? But imagine what kind of situation you could be in where you might get a perfectly precise number, absolutely exact. Is there such a thing? Well, think about this question. How many fingers do you have? Or how many students are in this class? Or how many minutes are in an hour? Assuming you don't have any injuries to your hand or some other unique situation, you probably have 5 fingers. Do you have 5.0 or like 5.1 fingers? No, you have exactly 5, right? It's not, there's no uncertainty about that, right? How many students are in this class? Well, I don't know off the top of my head right now, but I know that it's a whole number, right? It's an integer, right? There's not going to be half a student that I'm unsure about. And how many minutes are in an hour? There are 60. By definition, there are always exactly 60. So there is a situation in which you can get an exact number. One is counting things. So like fingers, students. These are exact numbers. Not quite like measuring, okay? And if you have an exact number, like 5 or like 42, it would have an infinite number of significant figures. Because you have, remember, sig figs is a measure of precision and certainty, and you're 100% certain, so you have an infinite number of sig figs. There's another situation, which is conversions. Okay, so most conversions within a unit system have exact definitions and infinite sig figs. For example, there are 1,000 millimeters in a meter, exactly, by definition. There are 60 minutes in an hour. There are 12 things in a dozen, not 12 plus or minus 0.2, right? It's exactly 12. So most conversions will also be like this. The ones between systems are not always, but they do not contribute to sig figs in a calculation. Okay, you want your conversion to have more sig figs than your measured numbers that you're converting. How about a pause here for a question? Select the exact measurement. Pause and think about this and answer for yourself, and then come back. Okay, welcome back. So a few of these, let's just walk through it, I guess. A, 35,000 people attending an outdoor festival. Well, it it's counting people, so that's kind of tricky. Let's hold off on that one for now. A quarter pound burger. Well, is it 0.25000000 forever exactly a quarter pound? Probably not, right? It's a measured thing. It's something close to a quarter pound. A $10 bill. I'm gonna hold that one in place, right? Because is it like approximately $10 or 10 plus or minus a couple cents? No, it's I think it's exact. So a person's height would be a measured quantity. 5'6", there'd always be some extra something there. A bottle of apple juice containing 946 milliliters. That would not be exact. So now we go back up to A, and 35,000 sounds like a rounded number to me. So I think we can safely say that the $10 bill is the exact measurement. Okay, we'll stop here and come back with the next part 2 to talk about the rules of sig figs. So which numbers count, which don't, and how do you determine the number of significant figures to use. We'll come back to that next.